Scientific notation. We've all done it at one point in our life. But during this chapter, unfortunately, we have to revisit it again. So let's just go over a basic review of what scientific notation actually is. So scientific notation is just an easy way to express really big or really small numbers. So the typical, form of scientific notation that you will use is some integer times 10 to either a really small number, so it'd be raised to the n, and if we're trying to express a really small number, n would be less than 1. But if we were trying to express this really big number like 10 trillion something, n would have to be greater than 1. Pretty simple. The best way to really kind of understand scientific notation is to really just go over some examples here. So say if we were to have the number 8, let's just make up some random 8, 7, 6, 5, 9, 2, 3, 7, 6. So let's see what that is there. 876,592,376. So say I really want to express this in scientific notation just because I want to make my life a lot easier. So how would we do that? Well, we'd start, since we know this is a really big number, we would start all the way from the right side, right here. So you'd think about a decimal point right there. Let me put it into color there. So what you're going to do is you're going to move this decimal point so that there's only one integer, only one number left in front. Keep moving it. Boom. We're done at this very point here. So now, in order to really express the scientific notation, we have to count how many, from right to left we went. So it took us 1, 2, 3, 4, 5, 6, 7, 8, 9. So how we would express this is 8.7. You typically just want to keep, 3 numbers, but if you were to write out the whole thing, 8.7659237, and we said it was 8 over, so it'd be 10 to the 8th power. Okay, we could really shorten this up and say that it was 8.77 times 10 to the 8th power, if we wanted to. Let's try a really small number. Let's say we were to do, 0.007643928. Pretty small number, I guess. How would we express this in scientific notation? Well, it's the same principle kind of as last time, but instead of moving from right to left, we're going to go left to right. So it would be 1, 2, 3. That's it. So this number expressed in scientific notation would be 7.64398 times 10 to the negative 3rd power. Pretty simple. If you kind of just keep with that rule, then it makes life just a lot easier. But now let's go into a topic that many of you are really not familiar with at all. Significant figures. Significant figures. I think really the best way I can really introduce you to this topic is just through showing you this graph. And I feel like just walking through this will give you guys a really good understanding of it. Because sig figs for many are still confusing, and by the end of chemistry, some people just forgot all the rules right after the test. So I'm just going to make sure you guys are amazing at it, and for the year of chemistry, you're just going to knock it out of the park. So let's just dive into it. So it all begins with, your basic numbers right here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we can split these off into being either significant or not significant. Most of the problems arrive with the number 0. But the, basic numbers, 1 through 9, they're not terribly complex. So these are always going to be significant. It's just simple as that. You just kind of have to know that. If you don't see a 0, it's a significant number. So that's like if I were to write the number 457. Could you tell me how many significant figures are in that? Well, yeah. So every number besides 0 is always significant. Let's just think about that as first and dive into 0 after we finish this. Right? So how many significant figures are there? Well, we have 3 numbers here. 1, 2, 3. So that means we have 3 significant figures. That's really simple. Okay? So all the numbers besides 0 are just always significant. But let's dive into 0. So if it's at the front of a number, it will never be significant. So that's like if you had 074. I don't know why you would write it in that manner, but 0 in this case would mean absolutely nothing, and you wouldn't care about it. You would say, too bad, 0, you're not significant. Okay? But more commonly regarding this rule over here, you'll see the number like 0.794, okay? We said at the front of a number, it would not be significant. So in this case, 0 is at the front of the number, so it's not going to be significant. So then how many sig figs does this number have? How many sig figs does 0.794 have? Well, it has 3 because, as we saw over here, these numbers are always going to be significant. So 1, 2, 3. So this number has 3 sig figs. Not too terribly hard. Let's move on. What if it's between other digits? Then it's always significant. So that's like if I had the number 1014 So 1015. How many sig figs does it have? Well, we know that these numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9, are always going to be significant. So that means we have 3 there. But what about the 0 in this case? Well, it's not at the front of the number, because if it was, it wouldn't be significant. But using the rule that we just learned between other non-zero digits, it's always going to be significant. And 1 and 1 are non-zero digits. So in this case, then, 0 is going to be significant. So this number here is going to have 4 sig figs. Simple. Not too bad. Those ones are really not that bad. The last one can cause some people some trouble, though. So let's dive into what the last one over there says. So it's talking about 0 at the end of numbers. Well, if it does not contain a decimal point, then it will never be significant. So how would that apply? So how does this rule apply? Well, that's like if I had the number, 1, 5, 7, 9, 6, 5, but then a 0. Then we have a 0. So how many sig figs do we have? Well, we know that all non-zero digits, like I've mentioned 1,000 times now, are always significant. So we know that the 1, 5, 7, 9, 6, 5 are all going to be significant. So how many does that give us? 1, 2, 3, 4, 5, 6. So we already know we have 6 sig figs. What about the 0, though? Well, since it does not contain a decimal point there, and it's at the end of the number, it will be never significant. So we are going to have a flat-out 6 sig figs. Done with that. Now let's go into our last rule, though, where it's at the end of the number, but, what else more about it? Just trying to remove all this stuff here. Okay. So it's at the end of our number, and it contains a written decimal point. Then it will always be significant. So let's look at what that would be. So that would be a number like 1.0. Just how many sig figs would that have? Well, we know that the 1 is always going to be significant, but what about the 0 in this case? Well, since it contains a written decimal point, this would also be significant as well. So this would carry 2 sig figs. What if we were to have the number 10.0? How many sig figs would that have? Well, we've got the written decimal point there, so this would be significant, this would be significant, and this would be significant. So this would have 3 sig figs. Well, that's all, ladies and gentlemen. I'm hoping this video helped you. And if you have any other questions, feel free to ask. Thank you.